Assalamu alaikum. Hello everybody. This is a very quick, very short video. It's about some basic question concerning sequences. So answer by true or false. Suppose that we have a sequence un which is unbounded. How so that the limit of un is equal to plus or minus infinity. This is false. We can take just this counter example. Un is equal to n power minus 1 power n, if you wish. In this case, if n is even, so we will get n, which goes to plus infinity. If n is even, it will be n power minus 1, which is 1 over n, so when n goes to plus infinity, it goes to 0. This is not true. The second question, if un is unbounded, so the limit of the absolute value of un is equal to plus infinity. Once again, this is false, and we can take the same example. We suppose that un and vn, two sequences which are bounded, so is un plus vn. This is true. We can just apply the definition of the boundedness. So there exists u1 and u2 such that un is less than u2 and greater than or equal to u1. The same thing with vn. If we add them side to side, we will keep that the sum is bounded. Suppose that un and vn are unbounded, both of them. So the sum is unbounded. This is false. Why this is false? Because we can take a counter example. If we take un is equal to n and vn is equal to minus n plus 1 over n, both of them are unbounded. But if we take the sum, since they are of various different signs, n minus n goes, cancel them, and we get un plus vn, which is equal to 1 over n. It is bounded. This statement is false. If we have un and vn which is bounded, so is the product of un with vn. This is true. Why? Because un and vn are bounded by some bounds. If we times them, we will get for sure bounds for the product. If un and vn are unbounded, how about the product? Unfortunately, this is not true. The product can be bounded. For example, if we take un and vn, un is equal to 1 over n if n is even, and n if it is odd, and vn we take the inverse. Vn we take n if n is even, and 1 over n if it's odd. If we take the product of these two sequences, we will get a new sequence, which is bounded. We suppose that un is bounded. How about one of un is also bounded? This is not true. We can take un which is equal to 1 over n, which is bounded, but the 1 over un is equal to n, which is unbounded. This is an equivalent approximatively question. If we take un which is unbounded, how about 1 over un? Is it unbounded too? The answer is false. We can just take un equal to n, and we will get 1 over un which is equal to 1 over n. It is a bounded sequence. The next video will be a little bit like this one, true or false, but it will concerns convergent and divergent sequences. Thank you very much. See you with the next video.